Okay, let's talk a little bit about acids and bases. One of the first things I want to do with this intro video is basically explain the two terms because this can be a little confusing. There's several definitions and several key characteristics between the two. So what I have on the screen currently is a Venn diagram. And you can see a lot of different points, bullet points on each side of the Venn diagram. I'm going to highlight just the most important ones, but I've got other information up there as well for you to look at. So one of the most important things you need to know about an acid and a base is the pH range. So this is a really common question that gets thrown out a lot. So you need to know that an acid has a pH lower than 7 and that a base has a pH higher than 7. Now, on the next video, I'm going to explain pH, what it means, how to calculate it. But for right now, just know these different ranges. We'll get into the formal definition of pH later. Another really important concept you need to know about these two terms is that when you put an acid in water, it will separate into hydrogen ions. And when you put a base in water, it separates into hydroxide ions. So you can think of this as a compound, an acidic compound. As soon as it interacts with water molecules, it will split apart into ions. Acids will split apart and produce H+. Bases will split apart into ions and produce a bunch of OH- ions. And we'll see some diagrams of that later. So these are the most important things you need to know. There are a couple other facts that tend to show up that are mentioned quite a bit in textbooks. One being that an acid has a sour taste and a base has a bitter taste. So like an acid you could think of like orange juice, kind of the taste of orange juice, and a base is going to be very bitter, taste like soap. Something else that sometimes shows up is that an acid is watery, whereas a base is slippery. So again, for a base, think of soap, and that will remind you of that the idea that it has a slippery feel. Now, there's a lot of other information on the screen. I realize that I'm not going to dig too deeply into those things, so I've just highlighted, if we look at the screen, 4 different bullet points from each side of this Venn diagram. Those are the most important ones that you need to know. Now, on this next slide here, we're going to get into some formal definitions. So this is where it can get a little confusing. Someone might ask, okay, well, what's a good formal definition of an acid or a base? On the last slide, you just gave me some characteristics, like what's the textbook definition? Well, this gets a little complicated because there isn't just one definition. It depends on what definition you're looking at. There's several. There are 3 very common ones, and I'm going to highlight just 2 of the more important ones with the concepts we're going to be interacting with. And the first one is the Arrhenius model. So Arrhenius' definition of an acid and a base is pretty simple. He said that an acid is going to be a compound that can produce hydrogen ions when you put it in water. And he went on to say that a base is going to be a compound that produces hydroxide ions when you put it in water. Now you'll notice in the formal definition that you don't see when you put it in water. In the definition you see a little bit more fancy. It says, the formal definition, acids produce hydrogen ions in aqueous solution. Again, we're talking about them being placed in water, interacting with water molecules. Now on the screen, I just have 2 particle diagrams. The one on the left here, and I'll point an arrow by these so you can see which ones I'm talking about. The one on the left here is HCl, and this is an acid according to Arrhenius' definition. Let's look and see what would happen, what he's trying to describe in the definition. So what he's basically saying is if you take this molecule HCl and you were to put it in a solution of water, it would separate. So the ions would disconnect from each other. And that's what he's talking about when he says producing H+. So they were connected together, but as soon as they interact with water, they split apart. Now on the right hand side of the screen, I'll draw some arrows over here so you can see what I'm talking about. You'll see that I've defined the term dissociate. This is going to be a word that's thrown around a lot. Dissociate is going to mean disconnect or separate. Basically all it means, and it's pretty simple, is that the molecule itself will break apart into its ions. So HCl was a compound made from 2 different ions, the H+ ion and the Cl- ion. When I put it in water, it ionizes or dissociates into these 2 ions. Now the other molecule that I have, I'm going to clear my screen here so you can see. The other molecule that I have here, and I'll draw more arrows so you can see what I'm talking about, is the Na plus OH minus, or sodium hydroxide is what this molecule would be called. It's going to do something very similar. When you put it in water, it will again separate. It will dissociate. And now you can see that I would have a bunch of Na plus floating around and a bunch of OH minus floating around. And according to his definition, if you can produce H plus ions in water, just like the HCl did over here, then you can be defined as an acid. Now, he also said that if you can produce an OH minus when you're dropped in water, then you are considered a base. Now, this is, again, just one of the definitions. Let's look at one that's maybe a little bit more confusing. So this one's a little bit harder for students, but again, I'm going to clear these arrows out so you guys can see. This is Bronsted-Lowry's model, what their definition is. And this is a definition derived from two different scientists, Bronsted and Lowry. And their definition is different. Their definition is an acid is a compound that is a proton donor, and a base is a compound that's a proton acceptor. Now, for this to work and for you to understand this, you need to realize that a proton and a hydrogen ion are the same thing. So if you think about it, a hydrogen ion is simply a proton and one electron. And if you, a hydrogen atom is one proton and one electron. That's all that's inside it. If you remove the electron from a hydrogen atom, you just have a proton floating around. So H plus, the hydrogen ion, and the proton are the same thing. So what are you going to do with Bronsted-Lowry's definition? Well, a lot of times you'll be given a chemical reaction, and I have one up here on the screen for you guys to look at. You're going to be given a chemical reaction, and you're going to be asked to identify the Bronsted-Lowry acid and the Bronsted-Lowry base. And this is not that difficult. So we've got our formal definition from Bronsted-Lowry on our screen here. We're going to go through and figure out who's the acid and who's the base. So the first one I'm going to look at is NH3. NH3 gets transformed into NH4+. So what I say to myself when I'm trying to figure this out, how did NH3 become NH4+? Well, it must have gained a proton. It gained an H+. So if you take NH3 and you throw an extra H+ to it, you will get NH4+, because you go from 3 hydrogens to 4 hydrogens. So since NH3 was able to accept an H+, it's the base. So we'll add our little base word over here to label it. Now, vice versa, if you were to look at the other reactant in this equation, H2O, H2O gets transformed into OH-. What did it do to pull this off? Well, to go from H2O to OH-, it has to have lost an H+. It has lost a proton. So H2O is a proton donor. So according to Bronsted-Lowry, H2O is the acid. So I realize this is a lot to take in for one video, but now you kind of have a little bit more formal definitions. You know a little bit about the characteristics, the pH ranges of an acid and base, and two different formal definitions for them. Like I mentioned before, we're going to have a whole video on pH and to cover that, but this gives you just kind of a good intro on the different definitions for that of an acid and a base.